Well, this particular video is all about the classifying of computer networks. So classification of computer networks can be done in variety of ways. The first one you can see on the screen itself, that it can be classified based on whether it is a peer-to-peer network or it is a server client-based network. Different references have been used for preparing this video, and they are listed on this particular slide. There is a book by Wiley, Internet Working LANs and WANs. Another book by Prentice Hall, that is Data and Computer Communication. McGraw-Hill has come out with this particular book, Data Communication and Networking, and the latest edition is there. You can refer this edition, and there is a training kit. So these four resources they have been used for making this video. So basically, you will wonder how many kinds of computer networks exist or how they can be categorized. What are the types of computer networks? So primarily, they can be classified based on the transmission media. So as all of you know, that transmission media plays a very important role in giving the bandwidth to the computer network. And depending on the bandwidth, the computer networks can be categorized. So whether a network is using a wired media or wireless media, this is the primary class of classification. And further, in wired, there are UTP cables, coaxial cables, fiber optics cables, and so on. Then another way of classification is based on network size. So whether it's a LAN, WAN, MAN, or nowadays even it is called as PAN. So all this network size means how many number of nodes are there in the network, what is the geographical area it is going to cover. So all these things comes into the network size. Based on management methods, so as I mentioned, peer-to-peer or client-server. So these two are again the classes based on the management methods or how the computer network is being managed. And then finally, we have seen a few videos on topology, whether it is having bus, star, ring, or tree topology, or even hybrid topology. Even we have seen that mesh topology is popular. So these are the basic methods by which the computer network can be categorized. We'll see the first one based on the transmission media. So under transmission media, there are two main categories. One is guided and other is unguided. So guided means there exists a physical channel from the node to any other node. So that means it can be wires or cables. And unguided means it basically uses wireless transmission principle. So there are different ways of doing this, like the radio wireless transmission or microwave. Infrared is also there. It can be transmitted in terms of sound and sonar. So based on these two methods, the transmission media based networks can be categorized. Uh, Basically, as far as the computer networks are concerned, the guided media they are being used for getting very good throughput. So amongst them, the major transmission media they are the twisted pair cables, and in twisted pair cables there exist two kinds of cables. One is unshielded twisted pair cables, and second is shielded twisted pair cables. Another transmission media which is popular is coaxial cables, and much popular is the fiber optics cable, which offers a very high bandwidth in the computer networks. You see this a very good you can say classification is given on the slide. That you can refer to it as a taxonomy of transmission media classification. So there are two main classes: the guided media, and the other is the unguided media. In the guided media, again there are three main types. One is coaxial cable, the other one is fiber optics cable, the third one is twisted pair cable. In the coaxial cable, again, there are two types. One is baseband, other is broadband. And in twisted pair, there are two types, unshielded and shielded. The other class, that is unguided media. So there are three main varieties here. One is radio waves, microwaves, and infrared. Of course, we are going to see details of all these things in this particular video. Let's come to the first guided media, and under that, the twisted pair cable. So you can see on the slide, the twisted pair cable diagram is shown here. So it is a twisting of cables. So it is a pair basically, and the pair is twisted. So here you can see the twisted. The layout, or you can see the cross section, is shown here, and this cross section And conceptually, you can see how the signal or the data is being transmitted from sender to receiver. You will wonder why there is a twisting of this kind of cables. So this twisting is done so as to cancel the electromagnetic interference or electromagnetic noise, and this kind of noise comes primarily from the sources like if you run a motor or if you start a vehicle, then actually there is a sudden surge of electromagnetic waves, and these waves they tend to enter in this particular transmission reception process, and then they often actually interfere with the transmission and reception of the data, and therefore they need to be cancelled. So by twisting the cables, so the interference is cancelled. That is the primary reason why there is twisting of these cables, and this is conceptually shown in this particular slide. On the other side, there is an unshielded twisted pair. So in this unshielded twisted pair, you can see that it is typically wrapped inside a plastic cover for mechanical protection. There is no shielding. So this is basically a plastic cover, and this is for mechanical protection or for protecting the cable from something called as moisture. So this helps a lot for that. And basically, this kind of sample UTP cable is shown in this particular diagram. And these kind of cables, they typically have many twisted pairs, like 5 twisted pairs. Okay, this is just for redundancy, so that it offers you the redundancy and you can connect many nodes at a time. And it comes with, there is a metal, and with this metal, the metal cable is shielded with the insulator, and this is again twisted, and such 5 cables, typically 5 cables, 5 and more, so they are basically enclosed in a plastic wrapper, plastic cover, and this way it you can get it in the market. And it is a very UTP cables are very popular for networking, for LANs basically. Shielded twisted pair, STP, so they are also similar to UTP cables, like unshielded twisted pair cables. So you can see the construction in this particular diagram. This is the copper conductor, which is being wrapped by insulator, and then there is a metal shield. This is a metal shield, and on the top of that, there is a plastic cover. So the plastic cover helps in basically protecting the cable from, you can say, moisture, right? And then there are actually such cables are there for and they are available in the market. uh, there is a metal. What differs it from the UTP cable is that there is a metal foil or braided metal mesh cover. Okay, so with the every insulated wires, there is a braided metal mesh cover. So typically, the construction is shown in this particular diagram. There exist a lot of varieties of UTP cable. As I told you that UTP cables are very popular, fairly popular in the networking, and they come in different categories like Cat 1, Cat 2, Cat 3, Cat 4. Cat stands for category, Cat 5 and Cat 6. So basically category 1, you can see it is the lowest quality. It is good only for voice communication, mainly in the very building. So basically telephone cables, right? So those are of category 1. Category 2 cables, they are good up till the bandwidth of 4 Mbps. Okay, and we have seen different kind of networks. Out of that category 2 cables, they are very good for, ideally suited for low speed token ring networks. So it is 4 Mbps. The category 3, there are at least 3 twists per foot. So in a foot there are 3 twists, and this particular cable, it can support a bandwidth of the order of 10 Mbps. So this is again common in phone networks in residential buildings. Category 4 cable, it can support a bandwidth of the order of 16 Mbps. So the token ring networks, which requires little faster data communication, you can go for category 4 cables. Category 5, or it is also called as 5 extended, it covers up to 100 Mbps. So this is common for the networks targeted for high speed data communication. So Cat 5, typically you will find Cat 5 cables in the networks wherein actually basically the LANs, you'll find that Cat 5 cable is very popular, fairly popular, and it covers up to 100 Mbps networks. If you're interested in gigabit networks, then you should go for category 6 and more, because nowadays even more categories are available. So this category 6, It has more twists than category 5, and it can support bandwidth up to 1 Gbps. So this comes under the gigabit networks. So basically, this category depends on how many twists are there per feet or per feet basically, and then what is the noise immunity, the immunity to the electromagnetic waves, electromagnetic interference it offers, and what is the speed it offers. And depending on the requirement, these cables can be deployed for the computer networking applications. As far as the coaxial cables are concerned, so you can see the diagram of the coaxial cables. So uh, coaxial cables, as opposed to UTP or STP, it has got plastic cover at the outer side. Then inside there is a insulator. You can see this is insulator, followed by outer conductor shield. Then there is again insulator, and then there is inner conductor. So this is the carrier of the data. This is surrounded by the insulator. Again, it is surrounded by outer conductor shield. This is again surrounded by insulator, and on the top of that there is a plastic cover which protects the cable from moisture. So these kind of cables, they can carry the signals of higher frequency right from 100 kilohertz to 500 megahertz. Okay, and the main purpose why the metallic wrapping is there, it serves both as a shield against noise and as the second conductor that completes the circuit. So you know that for completion of the circuit, it requires some kind of other side, and this particular the wrapping, it serves as the circuit completion mechanism, and plus it protects the main cable from uh, for the noise immunity purpose. So this is the main purpose of having the second conductor. On the top of this, all this, there are fiber optics cables. As you know, that fiber optics cables, they basically employ light as the carrier, and a light travels at the speed of 3 to 10 to 8 meter per second rest, second inverse in free space. And this is the fastest possible kind of speed in the universe, and therefore it offers you highest bandwidth. There is no other uh, bandwidth offering mechanism than the fiber optics cables. So you might have studied this in your graduation, that what is the basic mechanism of carrying the light in the fiber optics cable. The basic mechanism is called as total internal reflection. So this total internal reflection means the incidence angle of light. If it is more than the threshold, then it gets into the mechanism. It gets into the basically it there is called as this total internal reflection, and then it just gets into the medium where it travels further, and this way, by using the light, you can transmit the data. This is the construction of the fiber optics cable. It has got a core and cladding. So this core is consist of denser material. It is basically glass or plastic, and cladding is also the same material but having less density. There are two kinds of fibers cables. One is multi-mode and single mode. So by using fiber, the light bounces back and forth along the core, and the source of the light most of the time is LEDs. And if you want more coherent data transmission, you can go for lasers. Of course, there are advantages and drawbacks. Fiber optics offers you noise resistance because external light is blocked by outer jacket. It gives less signal attenuation, higher bandwidth. Uh, on the other side, the cost is bit higher because of the material and the manufacturing process, and maintenance is bit expensive because a simple crack in the core, there is a mechanism called as splicing, and the splicing needs to be adopted, and it requires a special machinery for splicing. So basically, we have seen the first category of categorization of computer networks based on the transmission media. So in the next video, we'll see the other type of categories like LAN, MAN, and so on. So thank you very much.